Hello and welcome back to the third and final part of the lesson on earned value analysis here on the Project Management PrepCast. We are on the home stretch of covering EVA in order to help you pass your project management certification exam. I'm your instructor, Cornelius Fichtner. In part one, we went through an introduction to earned value with some history on where the earned value methodology came from and introduced you to our exciting discussion on building houses to understand variances. In part two, we covered indices and forecasting, and now here in part three, we discuss the estimate to complete and the to complete performance index, as well as various miscellaneous formulas. This is a shorter session, and you have gone through the worst of the equations already in part two, but you still need pencils sharpened and your thinking caps tight on your head. Up until this point in this lesson, you have been calculating numbers and trying to determine your best option. You have done all of this work and you still need to report to your stakeholders. If you walk into a stakeholder meeting, however, and go through all these options with them, their eyes will glaze over, pop out, eyebrows will raise, and you will lose your audience pretty quickly. Never drag your stakeholders through all of these equations. It is rare that anyone appreciates the rigor. The best statement is to say, after thorough analysis, we think. Two questions will immediately follow. How much do we still have to spend, and how much more is that than our original budget? The first question is asking about the estimate to complete, or the ETC. We saw that when we talked about a scenario A in part 2 of this lesson on determining the estimate at completion. It's pretty simple to remember. It is the estimate at completion minus the actual cost so far. In the case of our bottom-up re-estimation, it's just the new estimate. So we have luckily done most of the math except for calculating the difference. The bigger issue is not getting confused between the two acronyms ETC and EAC. In real life, always confirm which one people are asking for. On the exam, always double check the question. For the second question, how much more is that than our original budget? The answer is also fairly simple. Just take the new estimate minus the old estimate, or BAC minus EAC. We call that the variance at completion, the VAC. Interpreting the VAC is similar to cost variance. If VAC is greater than 0, then your project is under planned cost, which makes people happy. If VAC is 0, you have no variance and your project cost is running as planned. If VAC is less than 0, then you are over planned cost and you better have a good reason or a recovery plan. Remember that it is a variance and it follows the rules of other variances. And that's it for the estimate to complete, and so we wrap up the equations with the one that has the longest name. That is the to complete performance index, the TCPI. However, to discuss this, we are going to return to the hypothetical family holiday in Japan that you won earlier on in this lesson. This is a great example of where you compare various indices on the road trip from Tokyo to Osaka when you are running late. The distance for your trip is about 500 kilometers. You are planning on driving at 80 kilometers per hour for a total of about 6.25 hours. You leave at 8 o'clock in the morning and you want to arrive at 2:15 in the afternoon. At noon, you check the odometer. You have only driven 250 kilometers and you should be at 320 kilometers. There are two questions. Do you go faster and try to make your original arrival time, or do you delay your arrival time? By the time we are done with this example, you can astonish your family with your EVA knowledge the next time you are late for dinner at a friend's house. All of this information that we've just seen gives you just about everything you need to determine your new arrival time options, and then you can make a decision which works best for you and your family considering the rest of your commitments. First, assume that you still want to arrive in Osaka at 2:15 in the afternoon as you had originally planned. This is equivalent to aiming for your original budget at completion on a project. So, you only have 2 hours and 15 minutes left. That's 2.25 hours. So first you need to figure out how many kilometers you have left as well. And that would be the total distance of 500 kilometers minus the distance you have already traveled, 250 kilometers, which tells us, well, we've only gone half the way. There are still 250k left to go in the journey. To determine the speed that we need to drive, well, you divide the 250 kilometers by the remaining 2.25 hours, and the answer that we get is a little bit over 110 kilometers per hour to reach Osaka per hour schedule. It's actually 111.11 kilometers per hour. Another way to say this is that your performance, your speed, has to be at least 110 kilometers per hour to complete as planned. If we were to say this in earned value terms, you would say that your to complete performance index is a bit over 110 kilometers per hour. Well, just hope that your family members have watched this lesson as well so that they'll understand. However, if I remember correctly, then the maximum speed limit in Japan is 100 kilometers per hour. That means driving at 110 kilometers per hour for the next 2 hours and 25 minutes would probably incur a lot of risk of being stopped by the police, probably making you even later and having a speeding fine to pay on top of that. You also think about what got you into this condition earlier. If you have been going too slowly for so far, what makes you think you're going to be able to go faster? This is probably not a great plan. You had better determine what a reasonable new arrival time might be. You and your family talk it over and decide to forego one tourist attraction. You change your arrival time from 2:15 to 3:15. This is the new arrival time equivalent to a new estimate at completion. Targeting a 3:15 arrival time means you now have 3¼ hours left to cover the remaining 250 kilometers. In other words, you must drive 250 kilometers in 3.25 hours. The resulting speed is 77 kilometers per hour for the rest of your trip. This makes you and your family much more comfortable. You still have time to get your dinner date, and you feel that traffic has let up enough that you can maintain this speed. In earned value terms, your to complete performance index, the TCPI, based on the new estimated time at completion, is 77 kilometers per hour. You've done an excellent job of balancing risks and constraints to determine how to recover in a way that is acceptable to you and your stakeholders. This is pretty easy to understand. And so is this. The to complete performance index, the TCPI, is defined as a measure of the cost performance that is required to be achieved with the remaining resources in order to meet a specified management goal, expressed as the ratio of the cost to finish the outstanding work to the remaining budget. This definition provides the equation, the ratio of the cost to finish the outstanding work to the remaining budget. In the car trip example, the distance to finish is analogous to the estimate to complete, and the time is analogous to the remaining budget. Of course, on most projects you don't have to calculate how fast you are driving, but the road trip example gets the point across. Applying this formula to our housing project should show you how it looks on a project. We start by looking at what it is going to take to keep our original budget. If you think back, all we did was to take the original goal, the budget at completion, minus the distance completed, earned value, divided by the original goal, budget at completion, minus how far you actually have come, actual cost. The housing project is in its 14th week. Its numbers are: earned value is €400,000, actual cost is €420,000, and the budget at completion is €1.2 million. That works out to be €800,000. €1.2 million minus €400,000 divided by €780,000, €1.2 million minus €420,000. Doing the math, our TCPI is 1.025. This means that the CPI in the future must be 1.025 to make the original budget. Looking at how our project operated up to this point, it seems reasonable that we could set a goal of a CPI at 1.025, which is not much greater than 1. If, however, on the other hand, we learn that the new freeway, the hypothetical freeway we already talked about, that's being built is causing a shortage of concrete, and the delay that we saw in the third house is going to persist for the rest of the houses, we need to make other plans. Assuming that the issues will persist, there are a couple of options that we have for our house building project. Our preferred option is to add a week to each foundation to the current third house as well as the remaining 3 houses at a cost of €5,000 per house. That's an additional €20,000. This does not affect the earned value, actual cost, or budget at completion yet because we're just looking at options. Remember, to change the budget at completion, we would require an approved change request. But by saying that we have an option to add cost, we have created a new estimate at completion. We have a new EAC, which is now €20,000 higher than the original budget. The formula is the same as in our driving example. We take what we have left to do, divided by our new estimate, or BAC minus EV, divided by the new estimate, EAC minus the actual cost. And if you plug in the numbers and calculate it out, you end up with a nice and even 1.0. Or it says that our CPI needs to remain 1.0 for the rest of the project if we make this change. Since we have been able to perform this way so far, except for the foundations, for which we are correcting, we think that this is a very plausible plan. Now we just have to convince the stakeholders to accept the cost increase. How do you interpret TCPI results? When the TCPI is greater than 1.0, especially when you're late in the project, getting back to the original budget at completion or estimate as completion is difficult. This result is a wake-up call. You need to take corrective action. When the TCPI is less than or equal to 1.0, then for the rest of the project you have to perform at least as you had planned. This is feasible and you should be able to maintain your CPI. However, you surely have to continue to monitor the project, but there is no need for any further corrective actions. Sometimes stakeholders want to know how far you have come on the project. Are we 50% or 70% complete? Well, this has 2 answers, one based on budget and the other based on schedule. To address this, we have the percent spent calculations, where the percent spent is actual cost divided by budget at completion. So after the 14th week of our housing project, we are 420,000 divided by 1.2 million, or we are at 35% spent. Percent complete is earned value divided by budget at completion, or in our housing project it's 400,000 divided by 1.2 million, that's 33% complete. Your stakeholders may show concern that you are spending money faster than your schedule, but you can dazzle them with all the other information you have to assure them that it is not a major issue and that your variance at completion will be no more than €20,000. Now let's take a look at where we can apply the EVM methodology. It's obvious that it applies to classical waterfall project, but what about Agile? If you have done a lot of Agile project management, you are probably shaking your head already in disgust at all the work we just laid out in EVM, and I'm sure that many Agilists could revolt at my next line, but in many respects, Agile encompasses and enforces many of the core aspects of earned value. Take just one of the main concepts. Each sprint is supposed to complete one or more functional items. In fact, in many Agile circles, they say that the functionality has to be deployable. This is probably the hardest concept in EVM to understand. Complete means earned, and Agile actually has it built in. This means that you can align a burn down or burn up chart and iteration costs directly to a planned value curve. In fact, EVA quite nicely highlights iterations that do not achieve their goals. The biggest issue is determining when an item is done, and that is left to the team to mutually decide. Although not used by many organizations, Agile EVM does exist, and it is not as poor a fit as many would think. Finally, after seeing all that is involved, you may be wondering, whose responsibility is it to track earned value management measurements and when to determine an EAC? A lot has to do with the structure of the organization. In some organizations, this is the job of the project manager or a specialized team member reporting to the project manager. In other organizations, an earned value analyst may be responsible for earned value tracking across a set of projects. Many organizations use project management information systems to aid in tracking and reporting to ensure a consistent format and frequency. And why would you calculate an EAC? Because there is a stakeholder that asks for it, or you see that your variances or indices are too far off. In our housing project, our variances were only a few % off the BAC, and it was probably not worth the time to worry about recalculating everything. That, though, is a decision usually driven by reporting thresholds or risk tolerances of the organization. Whoever is doing it, you as the project manager need to know and understand what it means, which is what we hope we have done here. As we wrap up, here is a review question for this lesson. Which of the following formulas is the estimate at completion forecast for the estimate to complete work performed at the present cost performance index? Is it Formula A, Formula B, Formula C, or is it Formula D? As always, I will give you a few moments to think about this so you can select an answer. Please press pause if you need more time. The correct answer is C. BAC divided by the cumulative CPI. This formula assumes that what the project has experienced to date can be expected to continue in the future. Here are your takeaways for part 3. The estimate to complete is the estimate at completion minus the actual cost. This would in fact be the same as a bottom-up recalculation for the remaining work. The variance at completion, or the VAC, is the difference between the EAC and the BAC. Here, positive numbers are always better. The to complete performance index, that's the TCPI, tells us what our financial efficiency must be in the future in order to meet the budget at completion. Values that are less or equal to 1.0 are good. They mean that we simply need to keep our current levels of efficiency in order to reach our target. Values greater than 1 are more troublesome since we have to improve efficiency in order to finish as planned. The formulas that we discussed in these 3 parts of this lesson must be studied and practiced for the exam, but remember to read the question carefully on your exam. Terms like the estimate to complete and estimate at completion are easily misread under pressure. And that's it for earned value analysis. Until next time.